All right, for today's math message to go along with 2 days worth of lesson, we're going to start off with special cases. And I made this math message last year just to prove to you or show you a little bit more why these special cases work. So if you actually did the actual factoring out, so this is we actually learned way back in the beginning of the unit in section 9.3. So if you actually did the factoring out, you'll see why the special cases work. So I'll do a couple of these for you, and then you can do the rest on your own. So for example, number 2, if I did the full FOIL for this, right, here, right, okay. So if I FOIL this out here, I would get, x squared first, outers would be negative 7x, inners would be negative 7x, and last would be positive 49. So you're left with x squared minus 14x plus 49. So you can see the special case here. They're both perfect square roots, and the square root of this is 1, square root of this is 7. And so 1 times 7 is 7, and then double it, it gets back to negative 14. So it works that way. So if I do the same thing, like for number 5, for example, first outers, inners, last, if I FOIL it, I'm left with 16x squared minus, this would be, or plus, if I do the outers, 36x minus 36x for my inners, and then minus 81. So you can see that this inner and outer terms cancel out. So I'm left with 16x squared minus 81. Minus 81. Let me try that again. 16x squared minus 80. Oh my god, minus 81. So you can see it has to be subtraction. But if the perfect square root, the square root of 16x squared is 4x, and then the square root of 81 is 9. So again, when you do the actual special case and you actually, instead of multiplying the binomials, you factor the binomials, you're left with, you're left with this. So it's a minus plus. That's the perfect square roots, and it works like that. So hopefully just try numbers 1, 3, and 4 so you can kind of see that working out, and then you can do what we were doing more last week with these. So for example, if I did number 7, for example, okay? So I know this will work because this is subtraction, right? The square root of 81, x squared is just 9x. Square root of 4 is 2, so I'd write this as minus 2, right? And then, so now for this one, it's not a perfect square trinomial, it's a difference of 2 squares. So I'm going to write 9x minus 2, and then 9x plus 2. Again, by doing this, if I actually did the multiplication, this would give me a negative 18x and a positive 18x, which would eliminate that middle term, and that's why that special case works. Let's look at a perfect square trinomial for number 10. So here, I know that, yeah, it's a plus plus. I probably should have 9 because it's a minus plus, but this is going to be squared. It's already perfect squares, so this will be minus 1. Sorry, plus 1. Square root of 1 is just 1. And then this will be 7x. Square root of 49. X squared is just 7x. And again, thinking back to what we did above, 7x plus 1, if I squared it, kind of like I did for this one, right? It gets you back to something that looks like that. So yeah. So again, for the first step of these 2 days of lessons, I want you to take a moment and do this math message. Multiply 2x squared, 2x minus plus 5 times 2x plus 5, 4x minus 3 times 4x minus 3. FOIL this out so you can kind of see why the special cases work, and then factor the special cases, and now you have left to do numbers 6, 8, and 9. So hopefully that makes sense for the beginning of the math message or for the first 2 days of lessons.